Right? So it's basically shifting and then it's stretching. All right. So any questions on this one? All right. Okay, so let's say, oh, did I put that in the wrong spot? Yep, wrong spot. All right, so I'll let you start on this one. Let's say if you want to find the amplitude, period, and phase shift. Let's say for y equals 4, sine of 2 times x plus power of 4. Oh, quick hint. Remember, that has to be negative. So just do a quick hint before you get started. You want to rewrite it as y equals 4 sine of 2 x minus negative power of 4. Kind of like how we had to do with the formula for a circle. If it was plus something, we had to make it minus negative, just to match the formula. right, so again, we want to match it up with our formula. Okay, so we have the value of A times sine of, uh-oh, forgot my K. Sine of K, x minus B. We can line it up here with 4, sine of 2, x minus, pi over 4. Why'd I do that? Okay, so for our amplitude, remember that's absolute value of A. So if we line those up, that's just absolute value of 4, which is 4. Okay, for our period, remember that's equal to 2 pi over K, which is 2 pi over 2, which is pi. So that means the graph actually shrunk a little bit as far as side to side. Because instead of being a length of 2 pi for an entire period, now it's a length of pi. So it's a little bit taller, and it's kind of shrunk in a little bit. Okay, and our phase shift, which is, where'd you go? Actually, it's your B, which is negative pi over 4. Okay, which just means since it's negative, it's shifted to the left, which we already knew since it's the plus pi over 4 up there. So it's shifted left, pi over 4 units. All right, so if you want to find your interval, if, like I said, they didn't ask, but in case you wanted to find it. Remember, that's equal to B, and B plus 2 pi over K. So that would be negative pi over 4 to negative pi over 4 plus pi, which would be, if we wanted to find the exact spots, negative pi over 4 and negative pi over 4 plus 4 pi over 4. So that would be 3 pi over 4. So it would go from negative pi over 4 to 3 pi over 4. Make that 3. Okay, so that would be our interval. Excuse me. All right, so any questions on that one? Okay. Now this next example is a little bit of, not really tricky, but you have to manipulate it a little bit to make it match your formula. So I'll show you, leave that up for a few seconds. Make sure everyone's finished. All right. Okay, so let's say, for example, if we wanted to find the period, amplitude, and phase shift for f of x equals negative 2 times cosine of 3x, clean that up a little bit, 3x plus pi over 2. Now this one is a little odd looking because, as you probably noticed, it doesn't look anything like our formula. And before we can do anything to it, before we can find out the period, the amplitude, and the phase shift, it has to match our formula. So, must match the form absolute value of A cosine of K times X minus B. Okay, so that's the only way we can find all of that stuff. Oh, that K looks horrible. There we go. Okay, so it has to match that formula. So to do that, negative 2 cosine of 3x plus pi over 2, we have to get that x by itself, which means we have to factor out that 3. The only problem is we can factor out a 3 here, but we don't have a 3 to factor out there. So if we don't have a 3 to factor out, we put one there. Okay, so we have to factor out three to get x by itself. Okay, so how are we going to do that without completely changing everything up? So you have 3x plus, we have our pi over 2, but we multiply the numerator and denominator by 3. So just by doing that, we can now factor a 3 out of both of them. So we factor out our 3, which means we have negative 2 cosine, and we factor out our 3. So if we factor out that 3 and that 3, that leaves us with x plus pi over 6. So does that make sense? All right. So we're close to our formula. The only thing we have to change now is that minus sign. So we have to change the plus to minus. Okay, so once again, we have that negative 2 cosine of 3 x minus negative pi over 6. Okay, and that matches our formula of absolute value of A cosine K x minus B. Okay, so now we can find our phase shift and amplitude and period. Uh-oh, there we go. Okay, so we know that our amplitude, which is the absolute value of A, remember matching that up, it's now the absolute value of negative 2, which is just 2. Bring that up a little bit. Okay, now your period, which is 2 pi over K. Now we know our K is equal to 3. So it's 2 pi over 3. And our phase shift, which is just our B, is equal to negative pi over 6. Which lets you know it's shifted to the left pi over 6 units. But we knew that when we saw that plus in there. All right, so any questions on that? Like I said, other than having to kind of mess around with it a little bit, it's really kind of the same thing. You just want to make sure that that x term is, move it up a little bit, that x is by itself. And if it's not, if you had a 7x here, Then you'd just multiply this by 7 over 7, and then factor the 7 out of both of them. Okay. Still writing. All right. Sine and cosine pretty much fall under the same category. Oh, some more paper. Now we're going to look at tangent. So if you remember, let's say that cosine of t equals 0. Okay. Let's say when, and hold on, let me make sure I'm, oh, actually I don't even need to do that. That's probably going to make you more confused. Keep it nice and straightforward. Okay, so let's say if you have, that's off. Say y equals a tangent of some k times x. Okay. Now for tangent, the period is actually equal to pi over k. Now with tangent, you won't have as many phase shifts only because you really only have to worry about the asymptotes of the denominator equaling 0. So all the places where sine would equal 0 are your asymptotes. So the only thing you really have to worry about is whether or not it stretches or shrinks or anything else. So in between there, it can get a little bit wider. So let's say if we do a quick sketch of that. So you have your x and you have your y. And remember, you have your asymptotes at 0, pi, nope, that's pi over 2. And 3 pi over 2, and 5 pi over 2, and et cetera, and so on. Okay, and remember, it looks kind of like that. Okay. Now, at most, what you have to worry about, because no matter what, tangent will equal sine over cosine. That should be pi, yep, pi over, that should be pi over 2. I don't know why I'm thinking of cotangent for some odd reason. Let me write it down. So tangent of x equals sine over cosine of x, which means cosine of x can equal 0. So actually this is your, yeah, no, I had it right, pi over 2. That's right, because sine is 0 at 0, pi, 2 pi, and the rest of those. Okay. So at most, you're going to have a graph where in between those two, I guess you call them vertical asymptotes, it's either going to stretch or shrink. Oh, that should be over here. That should stretch a little bit. I'm confusing my graphs. So that should go through there. There we go. There we go. Okay, so it looks like that. So the most you have to worry about is whether or not this graph shrinks. Let's say if it stretches like that, or if it shrinks and it looks like that. So that's really the only kind of manipulation you have to worry about for this one. You're not going to have to worry about shifting as far as like left to right, because no matter what, the vertical asymptote does not change. Okay, so let's say, for example, and remember those. Let's say if we wanted to graph, and actually let me see if that's right, because it is a phase shift, so actually we can do that. But this is just for that simple form. So let's say, for example, I already wrote example, duh. If we wanted to graph y equals 4 tangent of x. Okay, so if we want to graph y equals 4 tangent of x, let's say if we have our pi over 2 and our negative pi over 2, let's say this is our regular tangent. Okay, so all the values where it equals, let's say 1, it'll now equal 4. All the values where it equals 4 will now equal 16. So all those values will now stretch up. So it will look kind of like that. So this is our 4 times tangent of x. And this is just our tangent of x. Okay, so all the values in there just multiplied by 4. Okay. So let's say if we decide, you know what happens if it does decide to shift? All right, so we know that tangent of x is equal to sine of x over cosine of x, which means if this one did shift left to right, so tangent of x minus b will equal sine of x minus b over cosine of x minus b. Okay, so oddly enough, our vertical asymptotes would shift with it. Okay, so let's say, for example, oh, actually, let me give out the entire formula first. For the in general, I don't think you need the proofs and everything. That'll just burn up a couple of minutes. If you have y equals a tangent of k times x minus b, remember the period is pi over k. The interval is actually negative pi over 2k to pi over 2k. Okay. Now remember, tangent keeps going up and it keeps going down. So there is no amplitude. It goes up to infinity and down to negative infinity. So there's no amplitude there. Okay. Now for cotangent k of x minus b, your period is also pi over k. And your interval is 0 to pi over k. And again, it goes right back to the phase shift, B units to the left or B units to the right. So for both of them, phase shift, and I'll put that down. Is your B for both of them. Okay. Now, if we're going for cosecant and secant, let's say y equals a cosecant k of x minus b. Your period is, again, 2 pi over k. And your interval is 0 to 2 pi over k, which ironically is the exact same for secant. So y equals a secant k x minus b. Where again, b is your phase shift for both of them. Running out of time. All right, so let's say, for example, I think with this one, oh, anyone's still writing? All right. Okay, so this is going to